Hello to all viewers of DIVI Group's Boiler Experience Sharing channel. Now, I would like to present the operating principle of the Biomass-fired Fluidized Bed Boiler designed by DIVI Boiler as part of DIVI Group. First of all, I would like to give a quick look at some kinds of fuel that can work effectively for this fluidized bed boiler technology, as follows: rice husks, chopped firewood, sawdust, cashew shell residues, coffee husks, and so on. In addition, the fluidized bed boiler can also use fossil fuels such as coal. First, fuel will be fed into the conveyor hopper, which is usually located in the fuel warehouse. From here, fuel will be conveyed to the intermediate material hopper of the boiler before being fed into the furnace of the boiler. At the intermediate material hopper, fuel will continue being loaded into the furnace with the help of the conveyor screw system. Relying upon the feed air system, fuel is evenly spread over the grate in the furnace. In the furnace, with oxygen and heat elements, fuel will perform its continuous combustion here. Hot smoke will go to the upper part of the furnace, where a steam generator tube is located above. The steam generator tube above the furnace, with water inside, will be heated by the heat of the fuel combustion stage in the furnace. Here, about 60% of the steam will be generated by the process of radiant heat exchange. Incompletely burned ash particles following the smoke will be collected by an ash collection hopper and returned to the furnace to continue being burned by an ash recovery fan. This is a very important part of a circulating fluidized bed boiler. Level 2 ventilation fan will provide additional oxygen for the combustion stage to minimize CO emissions into the atmosphere. After exchanging radiant heat inside the furnace equipped with a steam generator tube, a hot smoke stream will continue to enter the boiler's body, which is composed of tubes immersed in water. Water will receive the heat from the hot smoke through the tubes and transform into steam. The steam will be fed into the steam use unit by the main steam valve and piping system. Here, about 40% of the steam amount will be generated by the process of convection heat exchange. After exchanging heat inside the boiler's body, the flue smoke still retains a significantly high temperature of 250 to 300 degrees centigrade. Therefore, the smoke stream will continue being fed into the water economizer to take advantage of the excess heat remaining in the exhaust smoke to heat up the water before being fed into the boiler's body. The water heater has a structure where smoke goes outside the tube, water goes inside the tube. Here, water is heated up to 150 degrees centigrade, thus the water heater will greatly help improve the performance of the fluidized bed steam boiler. Smoke exhausted from the water economizer, remaining at 180 to 200 degrees centigrade, will continue being fed into the air preheater to heat up the air before getting fed into the furnace to effectively upgrade the process of fuel combustion. The air preheater has a structure where the smoke goes outside the tubes, the water goes inside the tubes. Here, the air is heated up to nearly 100 degrees centigrade, which will greatly improve the burnout ability of fuel and boost the performance of the fluidized bed boiler up to 89%. The ash collection hopper under the air preheater will help collect a part of coarse ash from exhaust smoke and remove it with the help of the rotary valve. And this is the main air supply fan for the combustion process. The air will move through the air preheater and follow the channel to enter the furnace for the combustion process. After the smoke stream is fully utilized for the heat, it will be fed into a dust multi-cyclone filtration system to collect most of the large-size ash particles. The dust multi-cyclone filtration system consists of many centrifugal dust-settling elements which are designed in accordance with British standards. Ash falling into the hopper will be removed by the rotary valve. The fine ash amount remaining in the exhaust smoke will be fully collected by a fabric bag dust filter system. The fabric bag filter consists of many filter bags. The smoke stream going through the fabric bags will leave the dust trapped and stuck on the surface of the fabric bags. When the dust layer is thick enough, the compressed air system will be blown into the bags to shake off the dust particles and let them fall into the ash collection hoppers below. The ash will be released by the rotary valve system. All ash in all dust treatment levels will be collected by the screw conveyor system and brought to the specified storage area. In some cases where the production line lacks condensate, the water fed into the steam boiler is completely cool, and the biomass-fired fluidized bed boiler system will also be equipped with a second water economizer in order to take advantage of the remaining heat in the exhaust smoke to heat up the cool water to maximize the use of the excess heat in the smoke to enhance the boiler's steam generation performance. A smoke exhaust fan system will assist the smoke stream in moving from the combustion chamber to the boiler's body, and then through the heat utilization devices and a dust treatment device at the back of the boiler. A water scrubber tank will collect all of the remaining ash inside the exhaust smoke by spraying water to wash the smoke stream. Finally, pure smoke will be released to the atmosphere through the chimney system. A de-aerator tank will help us remove oxygen components present in feed water for the boiler. As a result, the metal parts inside the boiler will be less corroded due to oxidation. A water tank will store a certain amount of water to assist the boiler in operating continuously for a minimum of 1 hour. A high-pressure water pump system will help distribute water from the water tank to the boiler continuously according to the steam demand of the plant. Before being fed into the boiler, water needs to be treated by the water treatment system to meet all the standards. A steam header will help us collect various steam supply sources from various boilers, then distribute to the loads that need to use steam. In addition, the steam header has a significant function in drying the steam prior to being used in the production process. The foregoing information is the entire operating principle of a biomass-fired fluidized bed boiler designed, manufactured and installed by DIVI Boiler. This fluidized bed steam boiler technology has been transferred to nearly 200 projects across Vietnam. Biomass-fired fluidized bed boiler technology, designed by DIVI Boiler, will help our customers meet all the standards of bilateral and multilateral agreements that Vietnam has entered, such as EVFTA, RCEP, CPT, PP, etc. We hope this video will help viewers partly understand the technology of a biomass-fired fluidized bed boiler. We hope to receive your comments in order to help us improve our products. Thank you. DIVI Group, bringing prosperity to companions from green energy.